Okay. Rightio. So just jump right in. So, how are people going with your uh, first assignment? Okay, those, yeah. Um, for one thing, if you're struggling with it, yes, you should be, in the sense that it is really a jump above what you've done in previous assignments. Yeah. So, what kind of things are you having trouble with? Okay. Yep. Okay. There's several different things going on there. One of them is just general programming skill and programming logic and that kind of thing. Um, Most of that you'll probably be able to figure out. Um, it just takes a bit of playing around and so on. What you have to kind of realize about C as a programming language is that it's high level syntax, but under the hood, it's all just machine code, right? And so any of the defenses or simplifications which are done in other programming languages to hide away what's happening, they're just not here. And so it takes a bit of struggling to get through it. Is anyone having kind of problems with spending a lot of time debugging silly little things, for example? Yeah, Putty itself has its those silly error messages. Oh, fantastic, Ross! That will actually cut down on your time, and in fact, that's what we're going to spend a lot of time today. Yeah, cool. So, what I want to spend today on, and I'm hoping, well, today and tomorrow, I'm hoping that this will actually help you not only with the upcoming assessment, because next week you've got another assessment which will start, but that it will help with this assignment. So if people are actually watching this or participating in this today, then that will give you a leg up on those who don't in terms of being able to debug what's going on with your assignment, with your assignment one. So this is kind of a bit of a demonstration of the things that I'm expecting you to know for the assignment 2 warm-up, which you have to do next week, but also things which you should be thinking about for even your assignment 1. There'll be some things we don't cover here that you might find handy later on. For example, debugging of memory allocation, because we haven't done that yet. But I think we're going to lay some good ground today for all of that. Okay? Well, that's my intention. Rightio. So, ideally we want to cut down on the amount of time we spend debugging software. And I can tell you many stories of having taught this course on campus and via OUA for, well, in the case of OUA only a year, but on campus for almost a decade, that the stuff that we will deal with today is going to save you hours of work, possibly just this week. I have seen situations where people have been messing with a bug for a week, like spending, 20, 30 hours on a single bug. And they've come to me and said, look, I can't fix this problem. And I have said, I hadn't at that time taught the debugging skills. I said, send me your code. I spent 5 minutes with their code. I had the fix for them. It is that powerful, what we're going to do today. Okay? So I just can't motivate the importance of what we're going to do this week too much. It's really important. Okay. So what we're going to do is we're going to look at, well, I want to focus really on these first two categories here, right? I want to focus on symbolic debuggers. Now, symbolic debugger, what it does is it actually reads, it opens up the binary file and actually reads the names of all the variables and the constants and all that kind of stuff, and then gives you an interface by which you can investigate your problem, right? And so we're going to be dealing with two of those today, GDB and DDD. There's a third one called CGDB, but that's not available on the server, but it says GDB with a prettier interface. Okay, a symbol is just a name for something. So if we think about your program, symbols are variables and functions, pretty much. They are the main kinds of symbols which get exported in your binary, and the debugger reads those. And you can then use them precisely, the exact names used in your source code. By default, that information is not stored because it gives additional information for someone that wants to crack your program, copy your program. And by default, GCC gets rid of all that information. In Java, by default in Java, that information is actually stored in the class files. And people, when they use debugging programs there, they're reading just what's already in the class files. Here, that information has to be placed in there. And that is done using the -G flag to GCC. Okay? So that's probably one you're going to find handy. Then we have memory debuggers. So there is a program that we're going to have a look at called Valgrind, which provides a way for us to, it reports on memory problems. And it gives quite a lot of information, and is actually quite intuitive, I find, once you get over your own hang-ups. Now, one of the problems that some of you, probably most of you, will have in using these tools is you go, oh, there's just a lot of text on the screen, I don't know how to read that. Well, I'm going to encourage you to be patient and read things from the top and make sure you understand what is there. It's no different in a sense to learning how to read compiler output. And I know for a lot of people, they don't read all the compiler output because they're like, oh, this confuses me. Learning what it means will be important and will matter. Now, I mentioned a program just then called Valgrind. We are going to be talking about that today, and we will come back to it again when we have a look at memory debuggers. Well, so when we are having a look at dynamic memory allocation in a couple of weeks' time. Okay. There's another program, or there's another trick we're going to use to help us with memory problems, and that's called address. So I always spell this wrong. Address sanitization. So what address sanitization is it's basically something that you can get the compiler to do when you're compiling your program, and it basically hardens your program. So a lot of things which the compiler lets you get away with because they're technically not correct, but they're within what's allowed by the standard. Those things will be disallowed by address sanitization. And I'll show you how to compile your program so that it is sanitized. Finally, we'll have a look at code checkers, code validators. In particular, we're going to have a look at a program called Splint. Now, that means Secure Programming Lint. And a linter is a static analyzer. So it basically has a look at your code and analyzes it for common poor practices and suggests things to fix it. The problem with code checkers or validators or static analyzers is that they can be overly fussy. And so they may ask you to fix things which you realise once you fixed actually weren't a problem. But then in fixing those things, you may uncover the problem. So that's where things like, well, what's commonly called linters, which are programs that actually check, that they validate your code and highlight any common problems that exist in your code. Okay? Not so much. That's the compiler's job. They do a lot more than what the compiler would do. So, probably an example of this might be, say, memset. Are people familiar with the function memset? You should be. It's an important one. So I'll just have a look at that right now. Okay. Memset. So this function takes in a pointer to some memory and initializes that memory, right? So I'll give you an example of that. So let's just create a program called setmemory.c. And surprising enough, an awful lot of the memory functions exist in string.h. Yes, you should be seeing what I'm typing. If not, make sure you're clicking on me. So make sure you click on Paul Miller, not Paul Miller 2, Paul Miller, and you should then see my screen. Okay. Yeah, Firefox is not so good. This seems to be worked fairly well with Chrome. Yeah. And I've tried to set the default settings for this meetup so that it should default to following me and that kind of thing. Alright here. So I've got an array of 80 ints, right? Now, let's just say now we've got no guarantee, for example, that each int will be a 0, right? We've got no guarantee of that. And that's an optimization that you may not want to initialize a memory. So if I just compile this as is, okay, so it just lets me compile it, it's all good. So now if I run set memory, see how these could have any old random value in it, right? And so I'll come back to this program, but this might be a good place to start with some debugging. So let's go back to our slides. We'll come back to this. Okay. So I'll also, let's have a look at these examples I've got. So lectures. I think it might be in week 5. Let's have a look. Alright, so if I... Okay, sig fault 1. Okay, I've got this program and it generates a segmentation fault. Radio. So what I'll do is let's have a look at the code for this segmentation fault. Well, I've got int star p and ID reference. What's the problem? You should be able to pick this out just by reading it, this one. Yes, but what's that mean? What's in P? Where does P point? No, it does not point at null. No, it could point anywhere. Local variables are not initialized. Well, we'll get into malloc soon enough. We'll start talking about malloc next week. That's not the issue. So if I just... Alright, I'm going to use GDB. Absolutely, it can point anywhere, and almost certainly it'll point at a memory address you have no right to. Okay, so I've just loaded the binary file here into GDB. But before I do that, what I should do, in fact, is when I compile, I use the same arguments as before, anti-wall, pedantic, but I use an additional one, minus G. So, so it's segfault 1.c. Now if I just do minus O segfault 1, right, it tells me, it gives me a warning about what's wrong, but so reading the warnings is essential to understanding what's gone wrong. Okay? But now if I just GDB segfault 1, if I see this here, this output here, reading symbols from, and then it says no debugging symbols found. What do you reckon is causing this? No debugging symbols. So yes, it was compiled without minus G. That's our problem. So if you have that, all you need to do is add the minus G. Rightio, so now, rightio, so all I'm going to do is I'm going to run it. Now, if I have a program like you will for your assignment next week and for your implementation assignment, you'll have arguments, you would type them here, the arguments to your program. But in my case, there's no arguments to this particular program, so I'll just run it. And what it says, aha, look at this. I've already got more information. It says that there was a sig v. So that's a signal sent by the operating system, a segmentation fault, and it says the problem is on line 12. Who already is getting more information out of this than what they have got through trying anything else? Yeah, this is really quite good to be able to get that information out. So that's one of the basic things we might use GDB for. It's so much more powerful, but this is a start. So now I know, okay, it's line 12. So then what I would do is open up the file in GDB, and I can actually specify line number to land on. So here, open up the file and land on line 12. And there's my cursor on line 12. And so, well, there's only one variable here. So that's our problem. So that's something. Okay, so that's sometimes you might find sometimes you might find that there might be a problem with -G, so you can actually use -G steps, and it solves that problem. It's when you're using certain libraries, -G might crash your program. So yeah. Yep. Okay, so let's have a look at so we'll have a look at this second SIG fault program. Rightio. So now we'll just compile this. Okay, this one gives us no problems as part of compilation, so we'll... Okay. So this is a bit of a tough one. You notice that everything that I've asked it to do in this program has been done, but I still got a segmentation fault. Anyone want to guess why? Right. So what's happening? What information is actually stored about a function? When we return the return, not so much the return value, but the address, of the next line of code to run is actually stored on the stack. So we've wiped that out. And we've put these other garbage values, which basically have corrupted the stack. This is what we call smashing the stack. You don't want to do it. Yes? Yes, that's... So, okay, what we'll do is, if you didn't know that stuff about array overflows and so on, you go, I can't see where the problem is here. And that's, most of you, like, some of you are going to have this problem with your assignment 1 if you haven't already, where you're actually going outside of the game board, right? So if you get a segmentation fault, and the segmentation fault is at the end of a function, and I'll show you what I mean. So we'll compile with -g, and now gdb sig fault 2, and I'll run it. And once again we get a segmentation fault. But look at this. This isn't in my code. In libc start main. So it's saying that main has caused a segmentation fault. Well, no, it's actually, this is the function that calls main. So if we did a backtrace, we're in libc start main, which is called from start, right? It's because main is not the first function which is run. It's the first function you wrote. Okay, now I want to know what the problem is in main. So I'm going to set a breakpoint in main, because it's a reasonable assumption that you are the problem as the programmer. That the people who have written the helper code for your program have probably debugged all of that. And so it's fairly unlikely that they have left a bug in there. You've created the bug, almost certainly. Until you get evidence to the contrary, assume that you're the problem. And that's generally a reasonable assumption. So I'm going to set a breakpoint in main. Right? So now we'll run the program again. It'll say, yes, the program is started already. Are you sure you want to start at the beginning? Yes, I do. Okay. So I type next to go to the next line. Now, I don't have the source code for string copy installed on this system. So if I type step, I just jump over it, right? All right, printf name. So remember, because of the rules about string functions, what do? We keep iterating over the string until we get to the null terminator. And we assume that we've got access to all that memory. It's your responsibility to make sure that's the case. But this string copy has already corrupted the stack. Right? Alright. Next. Okay. We're at the closing brace. Next. So it is upon return we dereference the memory address from which this function was called, and because I overrode the end of the array, I've caused a segmentation fault. Now, that may not be so clear, so let's try something else. I'm going to actually use Valgrind. So let's quickly have a look at what do the slides say about. Let's just see. Okay, we'll come back to that. Valgrind is a memory debugger. So we've already got a compile with -G, so that's all good. So let's try it with this program. How it works, we do valgrind / segfault2. Radio. So this is, it says here, invalid read of size 4 below main. Why didn't I get a segmentation fault inside the program, inside main? Do you think? Well, the memory addresses that we're overriding are actually, they're my memory addresses. I can do with them whatever I want. I only get the segmentation fault, or we only get the invalid access when we're talking about memory which is not mine. And when it tries to dereference that return address, because it's written over by garbage, that's where we get the problem. So you can see how we learn a lot about systems and how they work because of, and you need to know that for when you're programming in C. Now, one thing I want to, I'm jumping ahead a little bit, but I think it's important, is I want to show you how to use libasan as well. So libasan is a memory hardener. So what's that mean? It means that it's unforgiving about illegal memory accesses. So I'll show you how it works. So what I will do, firstly, I have to run a script to actually change the compiler I'm using because there's a bug with the default compiler. So what we'll do is we're going to use the source command, which basically runs a script in the current shell. So opt red hat dev toolset. Use dev toolset 4 because dev toolset 3 is likely to be removed possibly before the end of the study period. I've been told this by ITS, so rightio. So we run that and it just changes which version of GCC and other default libraries we're using. So, and you can see if we type version, it's a later version of GCC. Rightio. So what I'll do is I'll do exactly what I was doing before. Now, the annoying thing is that you'll have to run this each time. You have to run this command each time. So I recommend you use that you basically run it, maybe even put it in your login scripts or whatever, up to you. But and we're going to add another flag. If sanitize equals address. Okay. So now if we run our CPT220, okay, we've got all these pretty colors. So what we have here is, in fact, we have the error message up the top here. So stack buffer overflow. We already knew there was a buffer overflow, but this particular library has found it for us. And it's given us some memory addresses for the program counter, stack pointer, and so on. So it says, though, if we read down a bit, it says this is the location of the thing, of the frame in which the problem occurred. That frame has this one object called name. So it's likely to be caused by this name, right? And we've got here a stack trace. Actually, this is a lot better. I made a mistake, actually. I should also do -G, and you'll see why. So now, when I run it, you see my stack trace up here has CPT220 line 13 is where the problem is. So this has got more precise than Valgrind. It's got more precise to where the problem is. So what we're going to do is have a look on that line. And the other thing it does is it provides us with a memory map of where the problem is. And these numbers all mean something. So if I have a look at the red zone, is in fact areas that it's illegal for me to access. They're not mine. And then F4 is a red zone where part of the memory is mine. So the memory on this side is mine. So the 00 and the 02, that's mine. But this stuff at the end here, that's not mine. And so I shouldn't, if I'm accessing anything there, that's illegal. So that's what that memory map means. But the most important thing here, two important things. One is, what was this variable was being overflowed. So it's telling me that. And it's also telling me to have a look at CPT220 line 13. So let me have a look on that. And there it is. This stuff is, you can see how this is going to save you hours of work. If you spend the time to understand how these things work. It requires a little bit of investment of time, but you'll get the results out of it. Okay? So, any questions so far? In that grid, it's really just here. So the non-red, that's right. Okay. So there's a lot of information there that you may not know, and in fact, most of the information here I don't necessarily, I have to look up and reason through it sometimes. But the important thing is this stack trace, the list of the objects, and what here, the fact that it is actually overflowed this name, and that gives you a bit of a picture of what's going on. Okay, so I'm going to reconnect. What I'm going to do this time is I'm going to specify that my terminal send X messages. X messages is the way that Unix type systems handle graphical user interfaces. And that's important because I'm going to use a graphical program on the terminal and have it display in a window on my local machine. So going back into shared, now what I'm going to use is I'm going to use DDD. And the program shows up in my local window. A little bit more complicated to do this with Windows, but I'll show you how to do it. Okay. It's taking a little while to load, because remember it's loading across the network. And one of the issues is that I'm broadcasting while I'm loading this, so that's part of the slowdown. No, it's a graphical. It's part of the GUI. Okay. Alrighty. So that's my DDD window. And what I might just do actually is change the fonts because it's a bit small, hey? So let's default all of these Just give it a minute to restart. Rightio. Rightio, so what I'll do is I'll open the program. CPT220. And there we go, we have our program. And so I can actually say right click and set a breakpoint. And then click the run button. And it says, so now I can step through. And in fact I can do stuff like, for example, right click, just give me a, oh yeah, and let's just say I want to display . name. And it gives me a little graphical output of what's currently in the name variable. And then I can click on next. Well, in this case, because I've still got, let me just, because I've still got the sanitizer there, so let me try that. So yes, that would do it, because a char array is many chars. So yeah. So now DDD Sigfold 2. So this can be a bit slow, although I think the main problem here, yeah. So it's probably more handy when you're using something locally. Yeah. Anyway, let's go back to our slides. Okay. Basically, a lot of people find this quite, find DDD quite useful to use, but it can be quite slow across the network. So that's up to you. But what I wanted to emphasize though is that getting to know these tools is only half the battle. The other half of the battle is in fact the technique of debugging. So I'm going to talk a little bit about that. Less so with slides than with actual examples. So let's see. Okay, let me just show you an example of a program that you might want to debug. Rightio, I've got in shared in, oh yeah, let's, I'm just using, yeah, Fedora with KDE. KDE is the desktop. So here's an example of a program. Do people, have you heard of what a cipher is? Okay, what's a cipher? typically it's the example here is what's called a Caesar cipher, right? And so in a Caesar cipher, we shift each letter down by a fixed amount. For example, we might add 2 onto each letter. And so what that means though is that X would be, so A becomes C, B becomes D, E becomes F, but at the other end, X becomes Z, Y becomes A, and Z becomes B for a shifting size Caesar cipher of size 2. So this is the way it's supposed to work. Okay, Fubabaz. And I'll shift it by 2. Right, so you see that F becomes H, O becomes PQ, and so on. Okay, so that's the way it's supposed to work. But let's just run the buggy version, Caesar. Okay, doesn't do anything. So our first step might be, well, first off, let me just CP minus R okay, so I've copied those files to my local directory here. So now okay, I think I made a mistake there. Okay. Easy. Ah, yeah. That's why. Yep, cool. Rightio. So now, alright, so what we do is, let's have a look at our program. So our first problem is, why is it exiting like that? So maybe what we might do is compile it with ANSI more pedantic audio, and it says there's some warnings here. They might give us a few hints about things which are wrong. So first off, okay, it says shift makes a pointer from an int without a cast. So let's have a look at that. So we can grep get int okay. It accepts an int star. In Caesar.c, line 45, what's shift? Yep. So let's have a look. Shift is an int. So it's fairly likely that we want, yes, you may want a pointer, but simply declaring it as a pointer may not be the right thing. In fact, this looks to me like we really want the memory address. So that's something that I get from experience. I know that's the case. Okay. So okay, that got rid of our compiler warning. That's good. But does it run or do anything useful? No, it still doesn't do anything useful. But yeah, what I would do as a start off here is maybe check if there's any memory issues, because memory issues, my spelling hits again. Alright, if you see this, you need to type that line source opt / Red Hat DevToolset 4 enable. Right? Alrighty. So if I type Caesar here, okay, there's no memory problems. So it's just some crappy coding on my part. So I might actually bring it into GDB. So set a breakpoint at main, run it. Okay. Boolean cont equals false. So I'm just typing next for each of these. What's going on there? Can anyone pick up the problem here? Yeah, but why doesn't it loop? Correct. I've got things wrong. Yeah. So, alright, then we'll rightio. So I set that to be true. Well, that would be the changing the meaning of the code. Now you see here, I have various comments here that they're meant to help you. The comments are meant to give you a hint about what the code is supposed to do. So if the code does one thing and the comments say that the code should do something different, the comments are right. The code is wrong. So I guess what that means is probably one of the first things you want to be doing is reading my comments, reading the documentation, making sure you know what the program is supposed to be doing. And then figure out why it's not doing it. Okay? And alrighty. So now let's see, we'll try recompiling it. Radio. Fred. Okay. Still we've got some problem because it's reading in Fred and then it's quitting. Let's try running it through GDB again. Anyway, you get the idea that basically you should use these tools to find the problems. So I set a breakpoint. If this was a program which accepted command line arguments, you would then type run space and whatever the arguments are. In this case it doesn't accept arguments, so don't worry about that. Then just step through it. Okay. Often what I do is I stay in this function until I find what the problem is. So I just type next here. So what value is in res? Print res. Oops. Print res. Okay. So res, let's just have a look at that. So empty is -1. So what's it doing? Should that be -1? Well, what does if res mean? Yes, but what is res? Yes, good. It's an enumeration. So when I use it in an if statement like this, what am I doing? Not so much 0 or 1, 0 or what values equate to true? Well, no, could be a negative. Any number but 0. So any number other than 0. So this is going to go in here even if I read something correctly. So there's that, right? The fact that it would actually quit on success. So what should this line be then? Correct. No, not if it's empty. Right? Because success would mean we want to continue. Right? Empty means the user pressed Control D. Yeah. Yeah, that's fine. I guarantee that what you're going to find though is when you peel back one bug, you find another, and you're going to find another. So there's a investigation kind of approach going on here. We actually look at what the problem is, and then we read what it's supposed to do. Go, okay, how can we fix that? And I'll give you a bit, basically what I'm going to do in the chat tomorrow is give you a bit more of a demonstration of a full program and what we expect you to do for the debugging exercise next week. Okay? Any questions? Cool. So hopefully you got a lot out of this session, and then tomorrow what I'm going to do is go through basically like a poker dealing program, deals cards and problems that it has, and the process of debugging that using the tools. Yeah. So, yeah. No worries. Okay, so best of luck. And I'll see you all tomorrow. And keep working on your assignment. Remember, it's less than a week to the due date. No worries.